Hi, my name is Chris Vollmer. I'm a storage architect out of Canada.
Hi, my name is Joe Dane. I am the Chief Architect for Spectrum Discover.
Today we're going to give you a brief overview or a talk about a storage for AI kind of driven solution. Something that we can think about, how do we actually apply AI and storage and the development of AI into a kind of real life example that gives our customers, our users, and even our partners a chance to say, this is something that I can use AI for that will actually change the world or make something different for us. Frankly, from our conversations, we have lots of customers that ask us, hey, how do I use AI? Where do I fit? Where does it fit? What's the right use case? And we've been in those conversations in TechU this week and a bunch of other places. But one of the ones that I thought was really interesting is the California wildfires. Yeah. And because of the impact that the California wildfires had last year, there was a project taken up between IBM and NVIDIA around testing something and actually trying to find a way to improve the detection and the understanding about how the wildfires are happening, how to combat them, and how to work with them. Joe, you were in some of that project. Do you want to do a little bit?
Yeah. Well, it's a fascinating project, and the idea is, well, how do you take AI and specifically looking at smoke detection and other types of AI techniques, such as, well, understanding how is the brush underneath the forest bed, how does that contribute to the fire, taking into account weather patterns and things like that, and putting it all together so that in real time we can actually help the firefighters on the ground do a better job. So more specifically, what we did is we took some drones and took some videos of controlled burns. And then those videos were cut up frame by frame, and they were then annotated to be able to identify smoke in the wildfires. And that was, once we did that, we were able to train an inference model for that, so that now you take that inference model and you put it onto these drones, and when there's a real actual fire, they can go use this information and use artificial intelligence to help predict, well, the firefighters need to go over here because there's a hot spot over here, and you're better off going to this portion of the fire versus focusing over here. So you can really limit the spread of the fire using these techniques, and it's an ever-evolving model that's continuously being reworked to improve the accuracy.
So I really like that. Let me go back and make sure I can say that back to you. And that was a lot. So let me see if I can say it back to you. Is the end result, the inference we built. The inference we built in partnership as we were developing this with NVIDIA was to be able to identify the places while wildfires were happening, direct the resources the right way, and use artificial intelligence to predictably find out where it could be or where some of the risk spots were. So at the end of the day, the inference was about helping us combat the wildfire to avoid the effects that we've seen before. That's where we ended up, right? That's what the goal of the inference was, right?
There's another part to it too, and that's keeping the firefighters safe.
Okay.
So you can use that same technology, that artificial intelligence, to tell them that they need to get out of there. Because it's going to go out of control and they need to get out of that area before something happens. Yeah.
So that end result, to go back to that idea, is the inference was actually then resides inside a drone so that it can send real-time data and real-time information and analysis, or maybe it's conclusions, real-time conclusions down to the firefighting teams?
Yeah, so the firefighters, they have devices that they can look at where they're receiving the information from the drones and the AI inference model, and then it gives them the guidance that they need to be able to make better decisions about how they're doing their firefighting.
That's very cool. Yeah. All right, so let's go back a couple of steps then. Now that we know now that I get a better sense of what the inference is going to deliver or what its goal is, how did we get that far? And you started giving us some of that around how we actually captured some of the data sets and then started to move it through that AI development pipeline. So let's start with collecting the data set. Use drones to actually collect the video of it. Was it existing fires or was it some of the controlled burn they're doing as a preventative maintenance?
Yeah, so it was controlled fires for preventative maintenance is the training data set that we use. So it's prescribed burns, and they obtain the videos from that, and then those videos are ingested into IBM Cloud Object Storage.
Okay.
And so you build a big data lake of all of your videos. And then from there, we use Spectrum Discover to be able to catalog and categorize all of that incoming data. So we can, for example, categorize, well, did this come from Livermore? Did this come from San Bruno? Did this come from another site? What was the drone that it came from? All kinds of curation and organization so that when you have this big data lake, you can make sense of it and organize it and understand what you have.
Gotcha. So you're building an information architecture, an IA in some respects that says, okay, as the drones come in with their video, because I'm going to do multiple drones and they're going to shoot multiple hours of video from these control burns, I want to put them in that central repository. So in this case, it was IBM Cloud Object Storage, built on-prem in the environment. And then from there, you're able to use Spectrum Discover. Talk a little bit more about that annotation and that curation around how Discover does that, and then kind of helps you either discover the data set or search the data set, right?
So, well, what we find is that data scientists, they spend a majority of their time trying to find the right data for their jobs.
Okay.
And Spectrum Discover is really aimed to be able to help that and significantly shorten that time to value and allow them to find that. And so when the data comes in and they tag it by site, where was the fire taken, or whatever the criteria may be, now the data scientists can search on that and be able to find the data that's relevant for their data set. So one example is, well, let's say that they were doing a controlled burn in San Bruno using what's called bounding box annotations.
Gotcha.
And let's say that the model wasn't performing the way that they wanted and they need to retrain. So within Spectrum Discover, they can go issue a query and say, show me all of the bounding box data from San Bruno, and I get this collection, this data set. So rather than having to manually sift through billions and billions of objects, you go to Spectrum Discover catalog, search on it, and it allows you to find that very quickly. And then from there, we take that data from the Cloud Object Storage and have a workflow that pushes it up to NVMe tier, ESS 3000.
Okay.
So that then it's directly close to the GPUs, and you can run your training model very, very quickly.
Okay, so let me go back on that for a second. We used Spectrum Discover in that case kind of two ways, right? One, to annotate the data sets. And you mentioned bounding box. Was that how they segmented, here's the area, here's the quadrant, here's the hectare, the acre I'm working through, in terms of you need to put a corral or an organization around that geographic spot, right?
Geo-coordinates.
Geo-coordinates, like GPS coordinates or longitude and latitude. And then from there, if I walk back through it, you say, okay, we've been able to curate and catalog the data from all of the different drones comes in, all of the different timestamps, you can search that. And then I can understand the bounding box areas, so I know what I'm going to push into the data scientist. And then as the data scientist is working through, say, okay, I'm going to actually train the model to look at this. So whether it is an area where I've seen smoke and multiple trees, I've seen kind of open plain and stuff, I can actually pull a specific data set towards the piece of the model that I want to train. And that's when we use Spectrum Discover we said promote, right? So we moved it from the object storage up into an all-flash NVMe storage array to be able to feed the GPUs that are actually going to do the building of the model, right? So that was the ESS 3000 as we moved the data from the object store up into the ESS 3000 running IBM Spectrum Scale, right? Okay.
And so the other part to that is we actually take the videos and break them up frame by frame.
Okay, cool.
And so you need to be able to take that video and in each frame understand where the smoke is. So you literally draw a box around the smoke, and then you do that for several of the frames, and then after you have enough of that baseline, you can train your model and then fully automate the process with inference.
Gotcha. And when you're doing that training, then you're going to actually push it all through the GPU. So you can do that training section and say, okay, here's the smoke, and this is a tree, and this is smoke, and this is a fire, and so it can start to understand what it's seeing. And we pushed it in the NVMe tier, so I'm thinking my way through that pipeline. And once we've pushed it in the NVMe tier, it's able to start feeding the GPUs residing in that DGX environment, right?
Absolutely.
So we work with NVIDIA DGXs to train these models. Give me a little bit more about how did that part work? They ran through their stack. Did we organize the workflows and the jobs so that they could have multiple inferences going at once or multiple training models going at once?
Yeah. Well, you can pick your TensorFlow container, for example, as part of the workflow. So you could have multiple containers running multiple different jobs. You can scale out the GPU cluster. You can scale out the NVMe cluster to fit your size. And you can run multiple things in parallel. The other part that's interesting about it is you can prefetch. So that you have this big.
So by prefetch, you mean you're starting to pull stuff ahead of time. Once one data set's flowed through the GPUs, I'm pulling more ahead of time. It's almost like I'm building a cache in some ways. And that cache is going to be ready to keep feeding those GPUs, keep pushing it through the DGXs, right?
That's correct. Well, and because one of the biggest problems is trying to keep those GPUs, working all the time.
Keep them spinning all the time.
And so there's some notion of prefetching in order to be able to keep those busy all the time to get the most use out of them.
Okay. Were we using Discover? How else was Discover? So as those models were coming through, how else were we using Discover in that kind of workflow? Was it then to catalog anything else coming out of there? Was it, how else did we leverage the manage of the data set?
Yeah, that's a good question. So as you're doing the bounding box, you get the bounding box, and you're going to get the coordinates on the image. We capture that output and add it back to our catalog.
Oh, okay.
So you're continuously enriching your knowledge. The other important thing to capture is what we call a score or confidence factor.
Yep.
So the accuracy of the model. Once you get to the inference, being able to capture that so that you can detect, let's say, I have a threshold for anything that drops below 90% accuracy. I want to be able to quickly find that data set, those images, and use them to go retrain my model to make it more accurate. And so it's this continuous process that you're always updating your model and making it better and better.
So you can build a better and better inference that way. So if I go back and think about that one for a second, so as the inference was able to understand what it's seeing, as it's seeing pictures, it's going to say, I've got a confidence factor, meaning I think this is smoke. I am mostly sure this is smoke. I am really sure this is smoke.
Yeah.
And then that's going to what? Eject tags. It's going to give me tags I can pass back in, so I can add those to the data into the data lake against those files, right?
Absolutely.
So that gives me the ability then to go back and go, okay, let me go search based on, well, how confident was the model looking at these images?
Yep.
Or if it picked up something else, some other attributes, through that, if it's ejecting other attributes, I can grab those attributes, and that goes into the data set as well. So now I can use Spectrum Discover to search all of the assets that came in, and then the outputs from the inference collapsed against those assets. So I can sort of see them linked together as one piece, as one data set to search?
Yeah, and then one example of that is that we actually used two different types of labeling. One was bounding box, and the other was what's called semantic segmentation.
Okay.
And so with bounding box, what we found is that you can draw a box around the smoke, but let's say there's some trees in front of that. That can actually throw off the inference model because you have interference in front of that bounding box.
Okay.
And so you can use Spectrum Discover to find bounding box data images that had a low confidence factor, and it turned out it was because there was a tree in front of where the bounding box and where the smoke was.
Okay, that makes sense, because it's interfering with how it sees the image,
yeah,
right?
So it couldn't interpret it correctly. So then we went to a more sophisticated labeling method called semantic segmentation, where it's more at the pixel level, and you think of it like a paintbrush. Like if you draw and paint over the pixels of where the smoke is.
Gotcha.
And that way you get rid of that interference of the trees, and you get an even more accurate model.
Okay.
Of course, there's a lot more processing required for that, but
that's I was going to say, that's a heavier piece of work, I assume, the painting. Is it a heavier piece of data preparation, and is it also more work on the GPUs as I try to train the inference because it's getting at a more granular level?
It's more granular, so there's more work that has to be done on the GPUs.
Okay, very interesting. How did you guys manage the workflow? As we went through this piece of work with NVIDIA, how did you manage the workflow to move all these pieces through? Was there different layers at the management of the workflow? Give me a little sense of how do we manage that? Because there's a lot going on in this pipeline, right?
Well, you think that, okay, so the data, let's take training, for example.
Sure.
The new data comes in. This is going to be our videos broken into individual frames. Those come into the cloud object storage. We catalog that into Spectrum Discover, and then we start doing some annotations and tagging on it to be able to organize it.
Gotcha.
And now the data scientists come in and, using the tags that we've defined in Spectrum Discover, do a search to find data sets for whatever their goal may be of what they need to train.
Okay.
And so then they find that data set, initiate a workflow that will then copy the data from this warm tier in Cloud Object Storage up to the hot tier that's next to the GPUs.
That's the Spectrum Scale ESS 3000, right? The NVMe tier? Got it.
Yep, and then you just repeat that process.
That's excellent. So going back to what the output was, once we built the inference, once you guys built the inference with the NVIDIA team, that inference got deployed where again? That got deployed inside the drones so that it's able then to feed real-time data. So talk us back through, it's the application, right? So I have a lot of people ask me, okay, once I've built the inference, how do I use the application? How do I use the inference? How do I apply it in real life so I can change a process, my interaction, my business procedures? And in this case, how do we get that connection from I have my inference now, we deploy it in the drone, and then we go from where? How does it work?
Yeah, that's a really interesting part of it, and that's where you put the inference model in the drone, so you have the camera in the drone, and you have some processing that's taking place, and the results of that can be then fed to this device, again to the firefighters have, that is giving them instructions and guidance about how to fight the fires. And so it's wireless connection between that, and it's just passing lightweight information about how to make the right decisions to better combat the fires.
And the firefighters are seeing that, in, for lack of a better way of seeing it, they have a special mask set up where they can wear it, and they also have a handheld device as well. So they'll get real-time information on kind of both inputs for them, depending how it looks.
Yeah, it's very futuristic looking, the mask that they have. But there's also a handheld device, and there's multiple options. And so with the mask, it'll show up right on the screen right there for them.
That's awesome. Including in that idea of continual training. Now, as the drones will fly, we're going to collect new data every time there's a new wildfire or there's a new burn cycle. So that then lets you go improve the accuracy, give yourself more training data. So you can almost keep that cycle on an ever-evolving path to refine the model, right?
Yeah, the more iterations you can go through, the more sample data you get, and the more retraining, and in particular looking at the score, the confidence factor, and picking out the ones that are not performing well. And taking that and retraining your model, you get more and more accurate, and it's just this continuously evolving model over time.
That's awesome. That's a really interesting use case. I think that's actually a really interesting, impactful use case of how it changes day-to-day life, and how hopefully it'll help what we're going to see in the coming months and the coming years in California. So thanks very much for walking me through it. That's fantastic.
Yeah, thank you.
My name's Chris Vollmer. I'm a storage architect from Canada, and
Joe Dane, Chief Architect for Spectrum Discover.
And thanks very much, guys.